My name is Anthony, and today we'll be looking at namespaces and exceptions. In today's objective, we'll be looking at namespace in C++. You'll get to understand the compilation and program structure you will be using. You'll get to understand the use of header files, and you also learn about exceptions. Now, when we say namespace, it's a feature that provides a way to group related identifiers such as variables, functions, and classes under a single name. So when you want to use a namespace in your coding, we first use the keyword namespace followed by the name. So this is a structure. So the namespace and then the name, and then whatever is in that name is the members. So defining a namespace called programming. So namespace called programming, this is how we are going to do it. So they are all under one thing. So you can see under it, you can see a void function. So and then the namespace is being called out. So let's take a look at this. Accessing namespace member. So to access a namespace member, using the scope solution operators. So if you want to access it, you have to use the scope operator, the scope resolution operator. So here's an example. As you can see, Now let's continue. So namespace with using directives. This directive tells the compiler that the subsequent code is making use of names in the specific namespace. So it tells the compiler that you are trying to use a specific namespace. So we are still using the namespace called programming, and then we are calling out what's inside the namespace. Yes. So you see, using namespace programming, and then you want to call out the method. So you want to call out what's inside. So you just type the func, and then you have called out what's inside the namespace. Let's continue. Let's get to know the types of namespace. We have the inbuilt namespace, the inline namespace, the anonymous namespace, and the global namespace. So for the inbuilt namespace, a namespace that are part of the C++, which contains most of the inbuilt in functions, objectives, and classes. It also avoids conflict between user-defined and library-defined functions or variables. So inbuilt, they are already in the system. So you just need to call it out, or you just need to use it. Yes. So the std namespace is a namespace that is part of the standard library, which contain most of the standard functions, objects, and classes like the scene, the cout, the vector, and etc. So this one is already in the system. So if you have to call out and you have to use it. So this one. So as you can see, this function, this namespace is an inbuilt namespace. Now let's continue with the inline namespace. And namespace where its members are accessible directly without using the namespace name. so you can access it directly without using a namespace name. Let's look at the anonymous namespace. A namespace does not have a name called anonymous namespace. It ensures that the entitled in the unnamed space are limited to that file. So it has no name. So here's an example of an anonymous namespace. Now let's look at exception heading. Exception heading. Exception heading is based on keeping the normal functionality of the program separated from errors handling. The basic idea is that errors occurring in one particular part of the program are reported to another part of the program known as the calling environment. The calling environment performs central error handling. The part of the program that performs central error handling in the calling environment is referred to as an exception handler. So you have to take note of these components of exception handling. There are two parts of implementing exception handling. The part of the program that can throw exception, and we also have the exception handler that will process the various exception types. Try and catch blocks. C++ provides an input feature for handling exceptions using try and catch blocks. It is an exception handling mechanism where the code that may cause an exception is placed inside the try block, and the code that handles the exception is placed inside the catch block. Now, throwing exception. Throwing exception means returning some kind of value that represents the exception from the try block. The matching catch block is found using the type of the throw value. The throw keyword is used to throw the exception. So you can see it. Now let's look at the throw exception types. There are three types of values that can be thrown as an exception. We have the inbuilt types, we have the standard exceptions, we have the custom exceptions. So the inbuilt types. Here's an example of the inbuilt type. So you just need to use the keyword throw, and we are able to use it. But they all have rules which you have to follow. Now let's look at throwing standard exception. So standard exceptions are the sets of classes that represent different types of common exceptions. All these classes are defined inside the std except. The header file and mainly derived from the std exception. So classes which act as the base class from inbuilt exception. So here's an example which I would like you to take a look at. Now let's look at the benefits of exception handling. So there's a separation of error handling code from normal code. Functions or method can handle only the exception chosen. Grouping of error types. We have separation compilation. A function definition in a function declaration in which the body of the function is presented. So here the structure, the function definition includes a return type, a name, a parameter list, and a body enclosed in curly braces. So these the steps, as you can see. Now let's go to header files. So C++ offers its user a variety of functions, one of which includes the header file in C++. All the header files may or may not end with the H. Header files in C++ are basically used to declare an interface, used to declare an interface of a module or any library. We have some components of header files. We have the function definition, the data type definition, and the macros. Now let's see the importing. So importing them into the program where importing them into the program with the help of a preprocessor directives that the hash include. These preprocessor directives are used to instruct the compiler that these files needed to be processed before compilation. Let's look at some types of header files. We have two main types. We have the standard header file or the pre-existing header file, and we have the user-defined header file. So for the standard header file, these are files that are already existing in the C++ compiler, where you just need to import them. So they are basically parts of the C++, or they are already in the C++, so you just need to call them. So standard header files are part of C++ standard library and provide commonly used functionalities. They contain the declaration for standard function, the constant, and then the classes. So yes, here are some examples of header files which are inbuilt or which are which is already existing, or it's already existing in the C++. Now let's take a look at the user-defined header file. These are defined by the user and can be imported using the hash include. These are mainly used to encapsulate our own functions, classes, or declarations so that we can organize our code, reuse our code by separating it in different files. Now let's continue. So you can see writing user-defined header file. So we say with H extension. So these are some examples, and then we have the format in which you have to proceed when using the header files. So you have to first know that when writing the header files, it has to end with a .h as its extension. So as you can see, someone is creating his own header files, which is called sum, with the .hash as its extension. Now let's look at the steps in creating a header file. So a header file should contain ordinary function definition, data definition, argreet definition, and unnamed namespace using directives. Now we look at programs. A program is a collection of separately compiled units combined by linker. Every function, object, type, and many more used in this collection must have a unique function. A program must contain exactly one function called main. We will look at program components. The main computation performed by the program starts with the invocation of the global function main and ends with the return for main. The return type of main is int, and here is an example. These are the ways which you can use them. Now let's see the program termination. The program can terminate in several ways. We have by returning from main, by calling exist, by calling abort, by throwing an uncatch exception, by violating no exception, by calling quick exit. So today you get to know about namespacing and exceptions. I'll continue with this session in my next video. Thank you.